Welcome to our next tutorial of Mesh2Surface for Solidworks. When you do your modeling in Solidworks, it doesn't matter which methods you use, if you use our tools or any tools that you have in Solidworks, you end up of having a bodies or surfaces, and which are standard features in Solidworks. But if you use a reference mesh, like this one on the screen, which is in this example, at any point you can just come and compare. The compare function will take all the visible SolidWorks bodies, will take the selected mesh, and will apply compare. The compare will give you a color plot of displacement of the scanned mesh against the solid bodies. The options we have here is what is our zero tolerance. We know that the scan data are always noisy. They have some issues in terms of they're not perfectly flat or not perfectly cylindrical. And that's why you need to have something which is acceptance for you. For example, in this case, you may want to work with 50 microns accuracy, or you want with the 10 microns, and you can adjust these values and type in here. You can press update and the software automatically will compare and will give you the deviation. What we see on the screen is the heat map of the areas that are within the tolerance of 5 times of the given tolerance. If the points are within 10 microns, in this example, they will be covered in green. If they are under or above the surfaces, they will be colored respectively with red or blue. Also, there are some areas which are in dark. This means that these points are not even compared. They're just out of tolerance, out of these 50 microns. In this case, I will just work with the 50 microns and press update. What we see on the screen also is the number of points that are in these 50 microns tolerance. So this gives you an indication and a total control of your quality of your models against the scanned data. This doesn't mean necessarily that it's something wrong, because, for example, here we have created our plane to be perfectly flat, but the data are actually not what we want. So it's up for the user to decide how to approach, if he wants to get the perfect accuracy or if he wants to make it design intent. One important thing that we want to say here is that the way the algorithm works is by comparing the scanned data against the graphics representation of the bodies from SolidWorks. Why I say this is that in this example here of the sphere, we don't compare the points against the sphere, but we compare these points to the tessellated mesh, a graphical representation of the sphere, and this is what we get as a result. So that's why in some cases, like this example of a sphere, or if you have a cylindrical surface like this one, you may get a result like this. Thank you for watching.